In this video, we're going to be talking about suggested homework problems from section 8.1. 8.1 is a review of our basic integration techniques that we learned in chapters 4 and 5. And we're going to learn more advanced integration techniques in chapter 8. But before we do that, let's review our basic integration techniques. So starting with number 15, 14x minus 5 to the 6th is, and dx is 14 integral x minus 5 to the 6th dx, for u is x minus 5, du is dx, so this is 14 integral u to the 6th du is 14 over 7, u to the 7th plus c. 7 goes into 14 two times, 2u to the 7th plus c is 2x minus 5 to the 7th plus c. Let's look now at number 17. Integral 7 over z minus 10 to the 7th dz. I'm going to pull the 7 out and make this z minus 10 to the negative 7th dz. My u is z minus 10. My du is dz. 7 integral u to the negative 7th du is 7 over negative 6. U to the negative 6th plus c is a negative 7 over 6 u to the 6th plus c is a negative 7 over 6 u is z minus 10 to the 6th plus c. Let's look at number 19. Number 19 is integral of brackets z squared plus 1 over 1 minus z to the 6th dz. So that's going to be integral of z squared dz plus integral of 1 minus z to the 6th dz. So that will be 1/3 z cubed, basic power rule. U is 1 minus z, du is a negative dz, so negative 1 and negative 1 give me minus, and then that is negative 6 here. So this is 1 minus z to the negative 5th divided by negative 5 plus c. That's 1/3 z cubed plus 1/5, and then 1 minus z to the 5th plus c. And the book expresses this as 1/3 z cubed minus 1 over 5 z minus 1 to the 5th. They factor out the negative 1 to the 5th, which is a negative 1, and it changes the sign. Let's look at 21. Integral of t squared minus 3 negative t cubed plus 9t plus 1 u is negative t cubed plus 9t plus 1. Du is a negative 3t squared plus 9 is a negative 3 times t squared minus 3. So I need a negative 3 and a negative 1/3. That's a negative 1/3 ln of the absolute value of negative t cubed plus 9t plus 1 plus c. Let's look now at number 23. 23 says integral of x squared divided by x minus 1 dx. Degree at the top is greater than or equal to degree at the bottom, so x minus 1 goes into x squared plus 0x plus 0. X goes into x squared x times x squared minus x. Change my signs and add x plus 0. X goes into x one time, x minus 1. Change my signs and add. So this becomes integral of x dx plus integral of 1 dx plus integral of 1 over x minus 1 dx is 1/2 x squared plus x plus ln of the absolute value of x minus 1 plus c. Let's look now at 25. 25 says integral of x plus 2 over x plus 1 dx. Again, degree at the top is the same as the degree at the bottom, so we're going to use long division. Integral of dx plus integral of 1 over x plus 1 dx is x plus ln of the absolute value of x plus 1 plus c. So at 27. 27 is the integral of quantity 5 plus 4x squared quantity squared dx. I have no basic rule for that the way that it's written, so I'm going to expand it into 25 plus 20 times 2 is 40 x squared plus 16 x to the 4th dx. It's going to be 16 integral of x to the 4th dx plus 40 integral x squared dx plus 25 integral dx. That'll be 16 fifths x to the 5th plus 40 thirds x to the 3rd plus 25x plus c. Let's look now at 29. That is the integral of x cosine of 2 pi x squared. I'm going to add parentheses for clarity. So u is equal to 2 pi x squared. Du is 4 pi x. So we need cosine of 2 pi x squared. We need a 4 pi x dx, multiplication by 4 pi on the inside, division by 4 pi on the outside. That's going to make 1 over 4 pi integral of cosine of u du is going to be 1 over 4 pi sine of u plus c. That's sine of 2 pi x squared over 4 pi plus c. Now let's look at 31. Is integral of sine of x over square root of cosine of x. U is going to be cosine of x. Du is a negative sine of x dx. A negative and a negative. This rewrites to negative integral u to the negative 1/2 du. So that is going to be negative u to the positive 1/2 times 2 plus c. It's negative 2 square root of cosine of x plus c. Moving on to number 33. 33 says integral of 2 over e to the negative x plus 1 dx. I'm going to use the integrating factor of e to the x over e to the x. So 2 e to the x over 1 plus e to the x dx is 2 integral of e to the x over 1 plus e to the x dx. We have our u is 1 plus e to the x. Our du is e to the x dx. This is 2 integral du over u is 2 ln of the absolute value of u plus c. It's 2 ln of the absolute value, 1 plus e to the x. I don't need absolute value bars because 1 plus e to the x is always positive. So let's look at number 35 next. 35 says integral of ln of x squared over x dx is integral 2 ln of x over x dx is 2 integral ln of x times 1 over x dx, where u is equal to ln of x and du is 1 over x dx, making this 2 integral of u du. It's going to be 2 times u squared over 2 plus c. 2's will cancel, leaving me with u squared plus c, and u was ln of x. Let's look at 37. 37 is integral of 1 plus cosine of alpha over sine of alpha d alpha, and that's integral of cosecant alpha plus cotangent alpha d alpha. That's negative ln of absolute value of cosecant alpha plus cotangent alpha plus ln of the absolute value of sine alpha plus c. The book is going to leave it like that. I'm going to clean it up a little bit here using some log properties. Sine alpha over cosecant alpha plus cotangent alpha plus c is going to make this, let's multiply by sine over sine to get rid of the reciprocal, the signs that are in the denominators and the denominator. So this is going to be sine squared alpha over 1 plus cosine of alpha plus c, and sine squared is 1 minus cosine squared alpha over 1 plus cosine of alpha, and 1 minus cosine squared alpha breaks up into 1 plus cosine of alpha and 1 minus cosine of alpha over 1 plus cosine of alpha, which will zero out, plus c. And the most simplified form to me is ln of absolute value of 1 minus cosine of alpha plus c. But the book is going to leave it all the way up here. All right, let's go ahead and look at number 39. (39) says integral of -1 over root 1 minus 4t plus 1 squared. U is 4t plus 1. Du is 4t dt. Sorry, 4 dt. A squared is 1. A is 1. So I need to pull the -1 out. I need to multiply by the 4 on the inside, 1/4 on the outside. This is 1 squared minus 4t plus 1 squared. So this is -1/4 arc sine of u over a 4t plus 1 plus c. Let's look at 41. Integral of tan of 2 divided by t over t squared dt. U is 2t to the -1st. Du is a -2. T to the -2nd dt. Rewriting this as integral of tan 2t to the -1st, something t to the -2nd dt. I need to multiply by a -2 on the inside and a -1/2 on the outside to make -1/2. Integral of tan u du is equal to a -1/2 ln of the absolute value of secant of u plus c, or 1/2 ln of the absolute value of cosine of u plus c, just bringing that negative up in there and taking the reciprocal, 1/2 ln of the absolute value of cosine of 2 over t plus c. Let's look now at number 43. 43 is integral of 6 over z root 9 z squared minus 25 dz. So u is equal to 3z, du is 3, dz. A squared is 25 and a is 5. I need to get a 3z down here, which means I have to multiply by 3 up there as well. So let's take the 6 out. Let's leave the 3 from the red part there up in the numerator to make du. We have u there. We have 3z, that's u squared minus a squared. So this is going to be 6 arc secant of the absolute value of 3z over 5. And this is also over 5 out here, plus C. So 6/5 arcsecant of absolute value of 3z over 5. Let's make sure that that's clear that that's a 5 plus C. Moving on to number 45. 45 says interval of 4 dx, 4x squared plus 4x plus 65. Interval of, let's leave this alone for right now. 4 times x squared plus x, and plus 65 out here. Half of the middle number squared is a quarter. 4 times a quarter is 1, so I added 1. I need to subtract 1. That makes 4 dz over 4 times x plus 1/2, 1d squared, plus 64. Everything is divisible by 4, so that's the interval of dx over x plus 1/2 squared plus 16. So now my u is equal to x plus 1/2. My du is equal to dx. My a squared is 16. My a is 4. So that's going to make this 1 over a arc tangent of u over a plus c. We don't like to leave fractions and fractions, so I'm going to multiply there by 2 over 2 to make this 2x plus 1 over 8 plus c. Let's look now at number 51. 51 is a differential equation, dy dx is equal to e to the x plus 5 1d squared. So dy is equal to e to the 2x plus 10 e to the x plus 25 dx. We will integrate both sides. Y of x is equal to integral of e to the 2x dx plus 10 integral of e to the x dx plus 25 integral of dx. And this needs a 2 and a 1/2 to balance it. Y of x is equal to 1/2 e to the 2x plus 10 e to the x plus 25x plus capital C. Now let's look at number 55. 55 says 4 plus tangent squared x y prime is equal to secant squared x. So y prime is dy dx. That's going to be equal to secant squared x over 4 plus tangent squared x. Dy is equal to secant squared x, 2 squared plus tangent of x quantity squared dx, where u is equal to tangent of x. Du is equal to secant squared x dx. So y of x is equal to integral of du over 2 squared plus u squared is 1 over 2 arc tangent of u over 2 plus c, y of x is equal to 1/2 arc tangent of x over 2 plus c. Continuing on now to number 59. 59 now is a definite interval, 0 to pi over 4 cosine of 2x dx. I'll make this 2 and this 1/2. That's 1/2 sine of 2x evaluated from 0 to pi over 4. Makes this 1/2 of sine of pi over 2 minus sine of 0. Sine of 0 is 0. So 1/2 of sine of pi over 2 is 1, is 1/2. So now it's 61. Says interval 0 to 1 of x e to the negative x squared dx. U is equal to negative x squared. Du is a negative 2x dx. This is 0 to 1 e to the negative x squared x dx. I'm going to make this a negative 2 on the inside and negative 1/2 on the outside. E to the u du comes back as e to the u, and we're going to evaluate from 0 to 1. That's negative 1/2 e to the negative 1 minus 1. So all these negatives here make this the same thing as 1/2 of 1 minus 1 over e times 1 minus e to the negative first. That's approximately 0.316. Let's go ahead and look at number 63 now. Says interval from 2 to 3, ln of x plus 1 raised to the third over x plus 1 dx. Be 2 to 3. 3 can come out front as a constant multiplier, ln of x plus 1 times 1 over x plus 1 dx. This is u. This is du. This is 3. Interval u du. This is ln of 3, and this is ln of 4. This is 3u squared over 2 from ln of 3 to ln of 4. This is 3/2 on the ln of 4 squared minus on the ln of 3 squared. So 1.5 ln 4 squared minus 1.5 times ln of 3 squared is about 1.072. Looking now at number 65. 65 says interval 0 to 8, 2x over the square root of x squared plus 36 dx. U is equal to x squared plus 36. Du is 2x dx. Integral u to the negative 1/2 du. Sticking 0 in for x to calculate its u value. Sticking 8 in for x to calculate its u value. This is going to be u to the 1/2 times 2, and this is going to be evaluated from 36 to 100. So 2 times the square root of 100 is 10, minus the square root of 36 is 6. 2 times 4 is 8. Let's look now at number 67. 67, 3 to 5, 2t over t squared minus 4t plus 4 dt. So u is equal to t squared minus 4t plus 4. Du is 2t minus 4 dt. So I'm going to subtract 4 and add 4. So that's going to give me two intervals, 3 to 5, 2t minus 4 over t squared minus 4t plus 4 dt plus 4 integral 3 to 5 of dt over t squared minus 4t plus 4. So this is ln of t squared minus 4t plus 4, evaluated from 3 to 5. This is 3 to 5 of t minus 2 squared. So if that's t minus 2 squared, this is also t minus 2 squared. T minus 2 to the negative second dt. 2 comes down front. This is going to be plus 4 t minus 2 to the negative first over negative 1, evaluated from 3 to 5. This is 2 ln of 3 minus 2 ln of 1. ln of 1 is 0, minus 4 times 3 to the negative first minus 1 to the negative first. So that is 2 ln of 3 minus 4 times 1/3 minus 1 is a negative 2/3. 2 ln of 3 is 4 times a negative 2/3 is 2 ln of 3 plus 8/3 is approximately, let's see what it is, 2 ln of 3 plus 8/3, 4.864. Now let's look at number 69. 69 says interval 0 to 2 over root 3, 1 over 4 plus 9x squared dx. My u has to be 3x. My du is 3 dx. My a squared is 4. So my A is 2. Need 3 dx in the numerator. So that puts a 1/3 out front. This is 1/3 times 1 over A, arc tangent of U over A, evaluated from 0 to 2 over root 3. This is 1/6 arc tangent of 3/2 times 2 over root 3 minus 1/6 arc tangent of 3/2 times 0. Arc tangent of 0 is 0. 2's cancel. Root 3 goes into 3 root 3 times 1/6 arc tangent of root 3. And arc tangent of root 3 is pi over 3. This is 1/6 of pi over 3 is pi over 18. Number 71. Negative 4 to 0, 3 to the 1 minus x dx. U is equal to 1 minus x. Du is a negative 1 dx. So that is a negative and a negative there. And this is going to be negative 3 to the 1 minus x over ln of 3, evaluated from negative 4 to 0. That's going to be negative 3 over ln of 3 plus 3 to the 5th over ln of 3 is going to be times 3 is 243 minus 3 over ln of 3 is exactly 240 divided by ln of 3. 240 divided by ln of 3 is approximately 218.457. And that's it for this video. We'll come back next time and talk about suggested homework problems from 8.2, which is integration by parts. See you for the next video.